In this video, I will walk you through free response question number 3 from the 2010 AP Calculus exam. This is an accumulation problem about people waiting in a line. It's based on this graph of the rate at which people enter the line. This is a calculator active problem. However, we don't really need the calculator to solve the problem. There are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph above shows the rate, R of t, at which people arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. Part A. How many people arrive at the ride between t equals 0 and t equals 3? Show the computations that lead to your answer. Here is one version of the first fundamental theorem of calculus, and I want you to burn this into your brain. It's one of the most important things that you will learn in the second semester of AP Calculus. The integral of a rate from A to B is equal to the net change in the amount from A to B. In this case, we have the integral of the rate at which people enter the line from time 0 to time 3. So the integral of this rate will equal the number of people entering the line from time t equals 0 to t equals 3. We are given the graph of r of t. To calculate the integral of r of t from 0 to 3, we must find the area under the curve from time 0 to time 3. So this area represents the integral of r of t from 0 to 3. Always keep in mind what this means in the context of this problem. The integral of a rate is the change in amount. In this case, the integral of this rate is the number of people who entered the line. Let's divide this area up into smaller areas that we can easily calculate. At first glance, I'm thinking this rectangle has an area of 12 because I see 12 squares. But let's be careful. Each square is actually worth 200 people. Look at the units on the x-axis and the y-axis. Each square has a width of 1 and a height of 200. So the area of each square will be 200. So this rectangle that's made up of 12 squares is actually 12 times 200. So this will be 2,400 people. This little rectangle right here, this 2 squares is 2 times 200. So this will be 400 people. Looking at this little triangle right here, 1/2 base times height. Well, the base is 2, so that's 1/2 2 times, and the height is 200. So this represents 200 people. Similarly, the triangle on the upper right is 1/2 base times height, 1/2 1 times 400, which is also 200. So this sum represents the number of people who entered the line from time t equals 0 to t equals 3 hours. Anyway, we found that the value of the integral from 0 to 3 is this sum, which turns out to be 3,200 people. Don't forget your units. And the bottom line is 3,200 people arrive at the ride between t equals 0 and t equals 3 hours. Part B. Is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? Justify your answer. The easiest way to decide if the number of people waiting in line is increasing or decreasing is to compare the rate in versus the rate out. The rate in is given by the function r of t. That's the graph that we are given, which shows the rate in at various times. What do we know about the rate out? The rate out is mentioned right here. People move onto the ride at a rate of 800 people per hour. So if people are getting on the ride, they are getting out of the line and going on about their day. So the rate out is 800 people per hour. 800 people per hour are getting on the ride and leaving the line. So now we just need to figure out if the rate of people coming in is greater or less than the rate of people going out on the interval from t equals 2 to t equals 3. If people are coming in faster than they are going out, then the line will be getting longer. If people are entering at a slower rate than they are leaving, then the line will be getting shorter. So let's look at the graph and analyze the interval from t equals 2 to t equals 3. Notice that at t equals 2, r of t is 1,200 people per hour. In other words, at this time, 1,200 people per hour are entering the line. Notice that at t equals 3, people are entering the line at a rate of 800 people per hour. So, on the interval between 2 and 3, people are always entering at a rate faster than 800 people per hour. The number of people in line is increasing because r of t is greater than 800 people per hour for values of t between 2 and 3. Part C. At what time t is the line for the ride the longest? How many people are in line at that time? Justify your answers. Part C is basically asking us to find the absolute maximum number of people in line during the 8 hours that this ride was in operation. And we know if we want to find an absolute maximum, we need to do a candidates test. The first step of making a candidates test is to find the critical values. If we had a function f to represent the number of people in line, to find the critical values, we would set f prime equal to 0. Since we don't have a function f, instead of setting f prime equal to 0, we will think of it as setting the rate of change equal to 0. This is the rate of change of the number of people in line. For a rate in, rate out problem, the overall rate is the rate in minus the rate out. So we set the rate in minus the rate out equal to 0. But we know that people enter the line at a rate given by the function r of t, and people leave the line at a constant rate of 800 people per hour. So now we have this equation. We can solve this by adding 800 to both sides. So r of t equals 800. We just need to find the critical value, the time, when the rate in is equal to 800. This purple line represents the rate out. People leave the line at a constant rate of 800 people per hour. This line is a graph of r of t, the rate at which people enter the line. We can see that the rate in equals the rate out right here at a time of t equals 3 hours. This is our one critical value. So on the candidates test, we will find the number of people in line at this time. We must also include the endpoints. So we will also find the number of people in line when the ride opens at time t equals 0 hours and when the ride closes at t equals 8 hours. In each case, we will find the number of people in line by starting with the initial number of people in line and adding the number of people who entered the line, and then subtracting the number of people who left the line. In the setup of the problem, we were told that there are 700 people in line when the ride begins operation in the morning. In other words, the number of people in line at time t equals 0 hours is 700 people. To find the number of people in line at t equals 3 hours, we start with the initial number of people, and then we add the number of people who entered the line between 0 hours and 3 hours. If you want to find an amount, you take the integral of the rate. So I will take the integral of the rate at which people entered the line, r of t, between time 0 and time 3. Then we must subtract the number of people who left the line. So we have to integrate the rate at which people left the line from 0 to 3. But that was a constant 800. So we will integrate that. So this expression says we have the initial number of people plus the number of people who entered from time 0 to 3 minus the number of people who left from time 0 to time 3. Let's use the graph to find the integral of r from 0 to 3. The integral of r of t from 0 to 3 is the area under the curve from 0 to 3, which I have divided up into 4 smaller areas. The sum of these areas is 3,200. So this is the number of people who entered the line from 0 hours to 3 hours. Finally, we need to subtract the integral of 800 from 0 to 3. There's a shortcut for calculating the integral of a constant. You just multiply the constant by the width of the interval. So from 0 to 3 is 3. So this integral will just be 800 times 3, which is 2,400. So we will subtract 2,400. Now here's the math behind that shortcut. The antiderivative of 800 would be 800t, but then we would need to integrate from 0 to 3. To do that, we find the value at 3 minus the value at 0, so that is 800 times 3 minus 800 times 0. But of course, the 800 times 0 part goes away, and we are left with 800 times 3, or 2,400. 700 plus 3,200 minus 2,400 equals 1,500 people. Similarly, the number of people in line at hour 8 will be the initial number of people plus the number of people who entered the line from 0 to 8 minus the number of people who left the line from 0 to 8. The integral of r from 0 to 8 will be the area we already found, 3,200, plus these remaining areas, as you see here. This is a total of 5,000 people. So 5,000 people entered the line from 0 to 8 hours, but now we must subtract the number of people who left the line. Again, when you take the integral of a constant, the shortcut is to multiply the constant by the width of the interval. So 800 times 8 is 6,400. This comes out to be negative 700, but you can't have a negative number of people standing in line. This just means that at some time between 0 and 8 hours, there are no people left in line. So the maximum number of people in line is 1,500 people, which happens at time t equals 3 hours. The line is longest at t equals 3 hours when there are 1,500 people in line. See Candidates Test. Part D. Write but do not solve an equation involving an integral expression of r whose solution gives the earliest time t at which there is no longer a line for the ride. The number of people in line at time t will equal the initial number of people plus the number of people who entered the line minus the number of people who left the line. The initial number of people at time t equals 0 is 700 people. The number of people who entered the line from time 0 to the unknown time t will be the integral of the rate in. Normally I would say r of t, but when you have an integral defined function, you need to use a different variable on the inside. So I will use x. Now we need to subtract the number of people who left the line. That's going to be the integral of the rate out from 0 to t. So the integral of 800. But we want an equation that gives the earliest time t when there is no longer a line. In other words, we want the number of people in line to be 0. We can simplify this integral using the shortcut I mentioned earlier. The integral of a constant will just be the constant times the width of the interval. T minus 0 is t. So we end up with 800 times t. This is the equation that, if solved for t, would give the earliest time t when there's no one left in line for the ride.